Hi, welcome again to my series of videos on data warehousing. In the last few series of videos, I went in some detail about the data warehouse workload, its definition. I went into many aspects of hardware, of how to correctly architect your hardware for data warehouse type workloads. I'm working your way up from individual disks to disk groups, LUNs, even some work with SQL I/O and into SQL Server with database files and file groups and how to properly set those things up for maximum parallelism. So I highly recommend that you watch those videos. They are foundational to understanding subsequent videos in this series. So for this video, what I'm going to do is I'm going to cover some of a kind of a range of topics, small topics in and of themselves. So I'm going to finish up our statistics, data warehouse statistics series of videos and complete CPU, measuring CPU. I'll also go over some general best practices as described in the fast track literature, and then I'll end this video with a demonstration of partition switching, something which I find is often overlooked in considerations for data warehouse architectures and processing of data, but is absolutely critical and continues to be critical for good performance of a data warehouse. So let's continue on here. So now that we've made our way through hardware architecture and went into some good detail there, we've made our way to the CPU. Now we have our disk groups laid out, we have our file groups set up properly, our database files, all those things are in place, and the next kind of thing to consider here is your CPU. Now, as I've mentioned in previous videos, this is usually not such a bottleneck for most data warehouse systems, but is something that you need to take into careful considerations. Many times data warehouses are not constrained around CPU, but more around the throughput. But CPU can be a constraint as well, and so it's good to make sure that you're able to accurately estimate your CPU utilization to correctly match that to in most instances, the query logic used by your queries, because it's really the CPU that handles the brunt of that. If you have very complex query logic, it's the CPU that takes the biggest hit there once the data makes it from disk onto the CPU. So now I've been focusing in on throughput and megabytes per second and all those kinds of things, and so for this we're going to switch gears a little bit and we're going to start talking about maximum consumption rate, estimating your maximum consumption rate. And kind of the first step here is to throw everything we've learned to one side and think about the performance of our CPUs from cache. So in the first series of tests that you want to perform, you want to do a theoretical max, or maximum consumption rate, MCR. And what this represents is you want to bring your data into SQL Server cache, SQL Server memory first, and then from memory execute a bunch of queries, leaving the data in memory. So this time you're not going to drop your buffers. You actually want your buffers full. And the reason for this is simply you want to test and get a good understanding of your processor's performance. How much data can it actually consume? And so these tests are performed from cache onto the CPU, whereas the other ones we were forcing SQL Server to get its data from disk. So what you want to do is set your statistics, I/O statistics on and your time on, and start measuring your queries and getting theoretical maximums here. Now it's theoretical because, of course, a portion of data will always come from disk and memory. So we just want to eliminate the factor of pulling data from disk and just use it from memory. Set a max degrees of parallelism to 4. The only reason to do this is because all the FastArc literature, because of the varying differences in CPU architecture and the number of cores and things like that, it's just a standard that all that documentation was written for, and so that standard needs to be maintained so that then you can you can run your queries and actually compare that against the fast track documentation, and you will be comparing apples to apples if you do that. And so I'm not going to go over and actually do an actual demonstration of this. But what you want to do is follow the same type of formulas that I've described previously in calculating how much data your processors can consume. So, and then what you want to do is, once you have your theoretical max, then you want to start establishing your benchmarks. And then this one, you want to drop your buffers and make sure you're pulling from disk, and you kind of execute the same types of queries, and you slowly increase the degrees of parallelism. And so what you're looking for here is how increasing the degrees of parallelism affects the run times for your CPUs. So this is assuming that, of course, your throughput, from your disk, megabytes per second, is all squared away, and that is all easily accounted for. And so now you're just getting your CPU performance times here. What I would suggest is that most data warehouse queries sometimes are very hard to predict, and so collecting this information about the types of queries can greatly affect CPU times. Very simple in terms of logical processes that need to be done. Queries can execute much faster than sometimes very complex queries that actually perform a bunch of low-level calculations. And what I mean by low-level calculations in terms of granularity, and then aggregate the results of those calculations up to higher levels. Those type of queries will take more CPU cycles. And as a data warehouse manager or a DBA or something like that, or an architect, you don't always have control or even knowledge of what kind of queries are going to be run. And so that's why I provided in a previous video the extended events framework that will actually help you capture at least most of that information. And in many cases, you can start dividing up, what I've seen, you can start dividing queries up into kind of three major categories in terms of their CPU utilization. You can have like a small CPU utilization, so those are kind of light query logic, kind of a medium bucket, and then a bucket of queries that are very complex and require lots of CPU cycles. And so that can give you, that's something I like to do in terms of generally segregating out queries, and because you can utilize the extended events framework that I provided, you can get that information very easily and start talking to the business and to other members of IT, the infrastructure people, about being able to support how mission critical are some of these queries, and being able to support some of this through either increasing the number of CPUs or cores, or decreasing the number of cores, depending on what your situation is. So that's kind of all I'm going to say about that. It's something that's very hard to talk into great detail, because each organization has their own specific requirements around the types of analytical queries they do in a very detailed manner. And so, again, utilizing that extended works framework, event framework, is probably your best bet, and just going from there. And as I alluded to in a previous video, page fragmentation or data fragmentation in general can have a tremendous impact on data warehouse performance. And so you can use the index physical stats DMV here view to get this type of information. And this is really important information, and it's something that always has to be maintained on a continual basis. And what you should be looking for is for your average fragment size in pages. Average fragment size in pages. You want to get something above 400, and what this metric is. And so you're always going to have fragmentation in your pages, simply because DML operations are performed. But you always want to try to minimize them below a certain threshold, and the best threshold here is about 400. And and the reason for this is this literally reduces disk head movement significantly and increases performance of your data warehouse as it's scanning data from those disks. And the only way to really reduce fragmentation is to rebuild your indexes on your fact table. So that might sound like a very costly operation, and on a very large fact table it typically would be. But what I will describe at the end of the video is how to break your fact table up into partitions. And so using partitioning, it isn't such an intensive operation, simply because then you are only rebuilding indexes on an individual partition. And usually once a partition, you know, it's the time window for DML operations has passed, and now it's just historical data sitting there. You can rebuild that index once, make sure the data is then finally in a pristine state. Historically speaking, it won't ever be touched again, and to just leave it in that partition for historical querying purposes. And so then it becomes only your most recent, partition or two, or however you're choosing to partition your table. Those are the only ones that are incurring DML operations, and so those are the only ones that you would have to, once they age to the appropriate time frame, then they can simply have their indexes rebuilt. And then you know that partition data is going to be pristine for the continued life of that data, and can be kept in that partition untouched. And that kind of approach will significantly increase your performance and reduce the average number of fragments that you have, average number of pages per fragment. So continuing on, so the results of that query look something like this. Here you go, you have average fragment size, and so that's what that looks like. Another really important SQL Server configuration here, best practice, is this trace flag E. Trace flag E is what this allows is for your extents to be created many at a time, and so this reduces your fragmentation. And this is a switch which is available in Configuration Manager. It's a startup parameter. Now, and the reason why I don't typically go into this much detail about how to actually configure something, but this is something that can be a little bit tricky if you're not paying attention, and has caused me a little bit of headache and heartburn in the past, and so I want to make sure that you know how to do this. So in SQL Server Configuration Manager, and also this isn't something that most people will typically do very much. There, you can select your SQL instance. Now I have a 2012 and a 2008 R2 instance, but my 2012 instance, I can select that and click on the properties, and then what that shows me is on my startup parameters, I've already inputted in -E. Now you need to be very careful, and this is why I'm going through this detail of actually doing this, is because if you put -lowercase e, now this is case sensitive, and then you add this, your instance will not start up. The services for your instances will not start, and there won't be any error message. There's no really nice error message. Or if you put capital E and then a space or something like that in there, again, it is case sensitive and space sensitive, I guess, and so it needs to be exactly -E. Anything else will cause the, particularly this is with SQL Server R2, 2012 is a little bit better, but it will cause your service not to start, your database service not to start, and your database will be down, and unless someone thinks to check this, it could be a real head scratcher for people to try to figure out what's going on, because it simply won't start, and there won't be any real error messages that will tell you why. So that's why I explained that. But this, again, this changes the number of extents that are automatically allocated into 64, and so that gives you 4 megabytes of extents that are auto allocated whenever a SQL Server thinks that a new extents need to be created. And so this is just a simple way of making the allocation in larger chunks. And so because the allocation will occur in larger chunks, your fragmentation will go down. Trace flag T-1117 is also another trace flag you can use. I don't use it all that much, but you can look it up. It's in the fast track documentation and see if it is appropriate for your particular situation. That's also another option. So, and again, here are some more SQL Server. Here's some more SQL Server general best practices here. So, you want to go ahead and carve out or allocate all the space required for your data warehouse database up front when you create that database. You don't want to have autogrow occur, because autogrow again just introduces more fragmentation, and this is on the file system level, but we have to worry about fragmentation there. So when you create your data warehouse database, go ahead and expand out those files and make sure that they cover all the space that you'll ever need. It also makes management a little bit easier, because this is one of the areas managing SQL Server and database file sizes that are continually growing. It's always hard sometimes to get how big the file is compared to how much room is left on the file system side. And so if you expand everything out and you know that's the maximum, and you know it can't get bigger than that, then you know exactly how much space you have left to work with. And then that information is all available in SQL Server, and it's really easy to estimate there. Again, that -e, that's an important startup parameter, and it'll give you extents essentially in 4 megabyte chunks to work with there. Autogrow, do not use autogrow if at all possible. Strongly push back if someone asks you if that's like your corporate standard or something like that. Strongly push back and say that's just really not appropriate for data warehouse workloads, and introduces fragmentation and things like that. And this type of fragmentation is really hard to deal with. You basically have to recreate your database files or something like that. So in terms of techniques here, now it says minimize the use of non-clustered indexes on fact tables. And so what that's referring to, so your indexing strategy for fact tables is really straightforward. You create what are called covering indexes. Maybe meaning you don't have any include columns or anything like that. You just create an index. Now this is for fact tables that are not on SQL Server 2012 or 2014, so 2008 R2 and below. You want to create one index per fact table column for your surrogate keys and your measures. You don't need to create an index for if you have any degenerate type facts that are just used for reporting out. You don't need to create any indexes, because hopefully you're not querying based on any of that kind of stuff. So no include columns, no vertical partitioning of your indexes. None of that will speed up your data warehouse at all, because you can't. These are ad hoc kind of queries, and you can't predict ahead of time what your queries will look like in most cases. So when loading in a clustered index, you want to make sure that it's ordered as possible when you load it in, and I'll get into that with partition switching. This is an important one. So for indexes, so if you're going to be maintaining those indexes, if at all possible, it is really good. So for when you're rebuilding your indexes, to use max degrees of parallelism equal to 1, and to sort it in tempDB. The reason for this is if you have parallelism going on in your rebuilding of your indexes, yes, your rebuild will go faster, but what will happen because of that parallelism, it'll actually be more fragmented than if you were just to let one core work on that index and rebuild it. So if possible, if you can make it within your window, maintenance window, just set your rebuild process to max degrees of parallelism equal to 1 and sort in dB. That way you get the most pristine index as a result of that rebuild, meaning pristine meaning lower the risk of fragmentation significantly. If you have volatile tables, you might want to separate those into different separate file groups. If you recall from a video from before, the Quick Start Data Warehouse actually has this. It has a separate file group for volatile data that has lots of DML operations going on in it, and tables as well. So periodic maintenance is a necessity here, and the necessity revolves around fragmentation. And of course, I've covered compression. So compression can be very helpful in terms of performance, and in terms of space used by your fact tables and things like that. So there you go. Now here's some best practices for loading. So it depends on if you're loading in parallel or serially into your fact table. So any of these best practices, when we're dealing with talking about getting really specific on how you load data and how data is maintained and things like this, I'm going to always implicitly be referring to fact data. Fact data is hopefully 95% plus of the data in your data warehouse. At least it should be if it's properly architected. So dimensional data is much less of a concern in terms of this fragmentation and all these kind of other issues. Usually most dimension tables are less than 1 million rows, and so they really aren't a consideration for any of this kind of thing. What you can do is you can batch load in parallel into like a stage table, and then from that stage table load into your fact table, your final destination fact table, serially in order to reduce fragmentation. And that's kind of what is being described here. Using a insert select from your staging table into a clustered index can also help reduce fragmentation. There is a great white paper out there that describes how to load data with minimally logged transactions. I would highly recommend that setting your transaction log to minimally logged anyhow to begin a simple transaction logs. There's no need to have any other type of logging occurring on your data warehouse server. So now I want to transition for the next 15 minutes or so into a partition switching demo. So partition switching is something I find in my experience sorely underutilized and really helps with the management of very large fact tables, which fact tables by design should be very large, and if they are very large, it means you're doing something correct here. So now I'm going to switch over to Management Studio and to show you an example of partition switching, and I'm going to assume that you don't know very much about partitioning, and so I'm going to kind of go through all the steps that are involved here in setting this up. So if you go to your Object Explorer, I'm using this test database, and in your storage here you have two directories, one for partition schemes and one for partition functions. Now you're going to create a function which is the definition of the partitions of your table, and then your tables data is actually going to reside in these schemes. And so and you can look for books online, exact syntax here, and so I'm just going to run through this stuff fairly quickly. But what I want you to keep in mind is that when you partition a table, essentially what you're doing is you're breaking one table into many subtables. And so your table now, whenever you query that one table behind the scenes, you can think of it as that it's now like a view with a bunch of union alls for those subtables that you've created, that you've partitioned, and so that's kind of how it functions. So now you can work with parts of your table or partitions of your table individually, and this can greatly increase the performance of your ETL and other DML operations, maintenance activities that you perform on these very large fact tables. So, and I'll go through an example of that. And so in almost every situation, what you're going to have is you're going to have a final fact table or a target table here. So that holds, this is the transaction or the snapshot fact table that you're setting up, and you'll have maybe one or more switch tables, what I call them. And so these are the tables that are going to hold these partitions that you're going to perform the DML operations in, and they're going to act as the switch to the final fact table. So and there's a variety of ways to do this. I'm actually going to create a separate functions. You can create a single function for both of these tables. I'm just creating two here in this example. So there's in my functions again have 3 partitions defined. Now SQL Server 2012, the partition limit has been increased to 15,000, which on a daily level is about over 40 years worth of history if you partition out your fact table at the daily grain, which is really useful because most fact tables kind of make sense to partition them out at the daily grain because your ETL load comes in usually at a daily basis as well. And most fact tables are already at a daily granularity. But you don't have to. You can decide however you want to partition out these tables and what makes sense for your situation. Now I'm going to actually create these schemes, and so this is what's going to actually hold the fact table data. So and I'm going to prefix them with a PS, partition scheme, and these partition functions are going to be partition function underscore the table name. This is just a naming convention that I like. And you can specify different different file groups, and in the quick start I showed you, this partitioning can get a little more complex because you're dealing with all those separate file groups, but here I only have my primary, and so I'm just going to create it on that. So creating my schemes like so, and so now if I go to my storage and I refresh it, I now have 2 partition schemes where my data will reside, and the functions for my partition table. My functions are going to be used for managing the actual movement of data or the switching of the metadata, as we'll see during the switch process. So now there's a couple of really important views that'll give you lots of really good information, the partition functions and then the partition range values. And so what this will give you is the name of your, as indicated here, the name of your, let me scroll it up, the name of your partition function, the function ID. This is used for referential purposes to refer to get other types of data, and then the value, so what the value is for that particular function. Now I didn't go over the whole range left and range right issue, and so I won't address that here. Books Online goes into that in great detail, but pick the appropriate range for the scenario you're working with. So now I'm going to create my final destination fact table, which is the target table here. And if you pay attention here, I'm not creating it on the primary file group. I'm creating it on this partition scheme, right? In this partition scheme, I'm telling it which column I want to partition this table by. So which column holds the values that I'm going to partition or cut up this table into subtables by. And so that's the only difference. I show you this create table statement for that exact reason, because I'm actually using the partition scheme, and you have to use these partition schemes when you create your tables, or the table will not be partitioned. So that has been successfully created, and the same goes true for my, in this case I have a separate scheme for my switch table. You don't have to do this, but I just did this just to keep things nice and distinguishing between the two tables. You can combine these if you want to. So again, my separate scheme for my switch table, and I'm specifying which column this table is going to be partitioned by. And if I look, so those are my partition schemes and functions. They're in place, and now if I refresh my tables are going to be there as well. So there they are. There's my partition fact table and then my switch table. So what I'm going to do is I'm going to populate my destination fact table just with a simple insert select statement. So this is just getting the table ready, pretending like it was already pre-populated with a whole bunch of data. You know, typically this will be hundreds of millions to billions of rows, but in this case I'm just going to put in 60,000 rows. Now I'm going to do the same thing for my switch table. I'm going to populate my switch table. So typically on a daily basis, your ETL process will populate your switch table. And what I'm going to do, the max date in my fact table is 7/31, and so I'm going to pretend like my ETL process is populating my switch table with the next day's worth of data. You know, 8/1 here in this case. And the important thing to know about the definition of your switch table, and I should have mentioned this earlier, is that your switch table has to be identical to your fact table. So identical index definitions, identical column definitions, data types, nullability, all those kind of things have to be identical for this to work. Okay, and so identical definitions on the tables. So now I'm going to insert that data like that. And that has now been inserted. And so if I look for my fact table, max date on there, and I'm partitioning by my order date key here, is 7/31 like I said before. And the data that's being ready to be inserted into my my fact table is sitting in my switch table is 8/01, the next day's data. So what I can do now, and there's a couple little things to use when you're making these commands that are very helpful functions. One of them is this $ partition function. So you can feed it a value, and it'll tell you what for that particular partition function. So this is a partition function of my destination fact table, what value, what partition that value should go into. So this partition number 2 of my, so I know that my data that I'm going to insert into my fact table is going to be for have this value in the order date column, and so I need to know what the corresponding partition number is in my destination fact table. And I can also, there's nothing in there. So the second thing to verify, so not only does your switch table have to have identical definition in terms of its table definition, but yet also when you do a switch, the target has to be empty. That target partition that you're switching that data into has to be empty, and so I can verify that it is in fact empty. If I take that number 2 and I and I try to select from it, I can see that partition of that table is empty. So good. So now I know my switch table is populated, and I know the target partition number that I want to switch into, and now I can do my switch. And so the actual switch statement itself is an alter table statement, and it always begins, and this is just the syntax of it, your source table, so my switch table. So I'm switching from my switch table, and switch, and the partition number I'm going to switch from on my source table is partition number 2, and then I'm switching to my fact table, which happens in this instance to have the same partition number for that particular data set. Now, this is not going to always work out this way, that your partition numbers match up. It just kind of happenstance that it does. And when I run this, what happens is a metadata operation, a pointer operation, that instead of pointing that partition number 2 of that fact table where it was, it now points to the switch table, and the switch table to the fact table partition. And so the end result is when I query this now, is that my max order date, instead of previously being 731 in my fact table, now is 801, because now that data is technically part of, that partition is technically part of the fact table and not part of the switch table anymore. And my switch table is empty, because now my switch table, that partition was switched. That empty partition in the fact table was switched. So the great thing about this is no DML operations have to occur. So if I have to insert, now these data sets are really small, but if I have a billion row plus fact table and I need to insert, I need to insert 10 million rows, that insert is going to take a while, because if that fact table has indexes and things like on it, all those things have to be updated. Well, with table switching, you don't have to worry about it. It's just a metadata operation that will always take, in my experience, less than a second to execute. So if I want to undo things, what I'm going to do is I'm going to alter table on the source table, the fact table, and it's going to be partition number 2 there, that I'm going to switch out for my partition number 2 on my switch table. And so I go ahead and execute that. And now everything is back the way it was. So now the max order date on my fact table is 731 again, and the data in my switch table is now appears to be back in there. That partition is now pointed at that 801. So you can imagine this is great for inserting, but also great for purging data. Hopefully your fact tables, you have a purge process that you don't keep data forever. Usually most people should have a window that they keep fact data for, 10 years, 15 years, whatever the situation is. But having to delete that data out of a very large table, let's say that's several billion rows, could be a very expensive operation. But with this switching, you just switch out the data you want, truncate the switch table, and then switch it back in, and that partition is now empty. Or conversely, if you for some reason need to perform some type of updates on the fact table, you can switch out that partition you need to perform updates on, perform those updates. They'll perform much faster because you're only performing the updates on the partition's worth of data, and then switch it back in. So any DML operation can be handled through this switching technique using partitioning. This is a very effective and a very efficient way to manage your fact data. Many times I see people incorrectly architect a fact table simply because they think it'll get too large. But with this partitioning, switching, it doesn't really matter how large your fact table is, because you're only ever operating against a partition of that fact table. And so it makes those operations much more efficient and much more easier to manage, and leads to correct architecture as well. So I will have more in-depth videos into how to handle fact table data, because it's something that is really, in terms of performance and maintainability of a data warehouse, critical to understand. But for right now, for introducing kind of the switching and partitioning of a fact table, this should suffice at this point. So next, I'm gonna talk about indexing and why indexing, go a little bit more depth into, I gave some general recommendations previously in this video, but I want to go more in depth into indexing and why indexing is beneficial, but only to a limited extent. And this will act as kind of a this basic indexing and strategy for data warehousing will act as a primer for talking about column store indexes, which are really kind of a game changer for data warehouse type workloads. So thank you for your time.